Hi there, welcome back and welcome to the second video in this restoration series. It's the Loewe-Opta Rheinperle 5717W and we've got it on the brackets, so we now are able to flip it around as I've shown you, and I'm ready to do the first few tests. The first thing I'm going to do is check that the output transformer is functional. Secondly, we'll check if the power transformer is functional. And if those two are fine, then we know we've got a viable restoration, or at least it should be. Let's get started. To test the output transformer, what I normally do is I connect a speaker to the speaker connectors of the output transformer, and then I'm going to inject a signal into the primary of the same output transformer. That signal is going to come from my signal generator, and I'm going to inject it at pin 7 of the socket. So what we get is the signals going in here, in there, and the other side should go to, well, it does go to the capacitor or the output of the power supply, in other words the selenium rectifier, but we can also just connect the ground of that signal to ground to the chassis, because all we've got on this side is a capacitor to ground, which is really a AC short, so it just makes it easier. So here we are, we've got 1 kilohertz, we've got 1 volts RMS, we're going to switch it on. I have the speaker connected to the 2 speaker wires coming from the output transformer. So that speaker is in line there now. And here we have the signal generator's signal coming in here. It's connected to chassis there, that's the ground. And I'm going to connect this to pin 7. So going counterclockwise from the top, 1, 2, 3, 4, 5, 6, 7. Can you hear that? Perfect. It looks like the output transformer is fine. Now bear in mind, it's not a guarantee. We don't know what's going to happen to the output transformer once it gets high voltage on it, because obviously the radio is completely off, out of the power. There's no high voltage on here, but that gives you an indication at least that the windings are in place. And it's a start, and it's a good start. Never failed me to date. So the next step is the power transformer. Now this is the plug, right? This is the mains plug in there, and it goes in here through a fuse into the transformer, through the primary, comes out here to a switch, out the switch, and it goes back to neutral or live. In this case, we don't have polarized mains. So if I want to check this continuity here, I switch on the switch and I measure the 2 prongs of the plug and see what we get. And it ain't good news. I've got the 2 prongs here. Oh, I haven't switched it on. Okay, I've got the multimeter on ohms measuring across the plug, the mains plug. I'm going to switch it on. I should get a low. This bloody thing's all over the place. But it's actually, let me switch it off. When I switch it off, it really goes to open circuit. If I hit it, it jumps around. Very high resistance, 9 meg. Let me try and hit it a bit more. It's trying, and that tells me something. It tells me that perhaps this thing isn't completely dead. It could be just a contact. We've got various points of contact here. We've got solder joints, we've got a fuse, and we've got the actual switch. So it could be a problem with those. Let's start eliminating the problems. So I know that one of these points comes to the fuse. Actually, it comes in the bottom. The mains cord comes in the bottom and it wires up to here, I believe it is. Not that one, let's try this one. Bloody hell, it's not that one. Where is it? Oh, there we go. Okay, so it's coming in from the main socket straight to there. That's going into the transformer. It should be coming out of the transformer here. Yes, 40 ohms. 40 ohms. So primary is not dead. Now I'm going to try and follow the signal. There's the fuse. I think I know the problem. This fuse is all crusted up. This is not through the fuse. This is the top of the fuse. I think we've got a contact problem here between there and there. So I'm going to try and clean that up. Okay, let me try clean that up now. There's a lot of crud on here. I'm going to have to do a more in-depth cleaning on this contact. Let me do that off camera and get right back. Okay, so it seems the fuse wasn't blown, but the contacts were very corroded. So if I measure here now, it's still jumping around. I think this is still... Never had so many problems with a bloody fuse before. 90 ohms. It's going through. And with high voltage, obviously it'll get through better. Let's see what happens if we try this again. We still don't know if the switch is fine. Well, yeah. We're getting 400 ohms. It's not what it is, but it's jumping around in the low ohm range. And if I hit this side, open, closed. And that's still got to do with a bit of corrosion on that contact, but we've got 400 and something ohms. We should be reading about 40 ohms, which is what we do before the fuse. So I'll clean the switch contacts as well and see if we can't improve that. The switch is that thing down there. And if I put it off, it switches it off. If I click any of the others, it switches it on. So I think it might be a little bit of corrosion on there as well, because it's still jumping around. Well, it's a bit more still. Off, on. Well, it's pretty stable now. And obviously with a little bit more voltage, like mains, some of that crud gets washed away. So it looks like the primary of our transformer is intact. Okay, next step. So what I'm going to do now is I'm going to give it, well, 1 volt RMS, and I'm going to give it 50 hertz signal. So basically I'm simulating mains, and in this case mains is 1 volt. Whoopee! And I'm going to feed that into the mains plug, as if our mains was 1 volt RMS. Let's see what we get on the secondary. So I have the multimeter on AC volts connected to the AC input of the selenium rectifier, which is the output of the secondary from the transformer. And I measure 0 volts AC. Now I'm going to switch it on, and we get 0.8. Now if I go to the amplitude here, and instead of 1 volt I give it 2 volts, 1.6, 3 volts, 2.5, 5 volts, 4.2. So it looks like our secondary is working. Now the full description on how this test is done, I've got the video, small video that I'll link above, but it does look like our secondary is working fine. We could also check the outputs to the light bulbs. That should give us a very low reading, but it should also give us a reading. But I'm quite confident this transformer is working as it should be. So which is great. We've got our two transformers apparently fine. Give or take some scrubbing of the contacts and cleaning contacts and changing a fuse, but I think we're making some progress. Oh, the things you discover when you start looking closely. Well, if you remember in the first video I scraped something off the top here and I said I didn't know where that came from. Well, it comes from that hole over there. So that capacitor is completely kaput. It's leaked its guts. And so I decided I needed to remove it. I wanted to restuff it, but there's a problem. This thing is very, very difficult to remove. I decided to actually replace it with two caps on the underside, and to do that I cut the wires and fit them in down there. One of them came to here, yep, to there. So that's the B+, the main B+ that comes to the output transformer. And the capacitor I've fitted across or just at the output of the selenium rectifier, so it's actually closer to the source. So it's not a bad option for locating it. The second one, well, it had a wire going from there, a blue wire that used to go back there, through that hole at the bottom there, and it came out the other underside. And I found where it went to and just replaced it down there. And this is where they are. The two are together. It actually fits quite nicely in there. Nice and snug. And they're actually quite, the grounds are very well soldered to the ground tag at the bottom on the actual rectifier. So they're actually pretty snug, but I might put in some hot glue or something, although I'm not sure how hot this gets underneath there. The other one actually comes to, where is it? Oh, bloody hell. Well, it's that blue wire that's coming there. I've heat shrunk it. It goes there, comes around and comes to one of these tags on the side of the board. And between those two, there's a 1K resistor, which is that black thing over there, and it's measuring spot on. So that part of the power supply is now done. I could and probably will, let me think about it. I'd like to test that power supply, but well, let me show you what else I've just done. That blue thing there replaced this dead thing here. It's a 4.7 nanofarad cap across the mains, well, from one of the mains legs to ground, death cap as it's sometimes called. I replaced with a safety cap. So I'm going in from the entrance point to the power supply as I've shown you, check fuse, check continuity, get to the rectifier, check the filter caps, found that they were leaking their guts, replaced that, and now I think I'm ready actually to disconnect one of these points. The only point that gets power after the first filter cap is that one over there. So I can very easily just remove this and check whether the power supply is working. Obviously the heater wires, heater winding, the heater supply would be in place, but if there's a short on there, we'll see that on the dim bulb tester. But I would like to see what voltage I get on there. If I remove that, then how does this work? Yeah, that's the first point. If I remove that, then there's no power going anywhere else, as we can see from the schematic. So that's probably the first thing I'm going to do. Let me think about it. Okay, so I've removed that connector, that wire, from the center tap of the output transformer. That's coming straight from the first filter cap. That is my B+. And it goes nowhere else because the continuity is broken here. So when I switch it on, I've set the multimeter connected to ground and to that to DC volts, and we should see what happens. Let's have a look at the dim bulb tester. Now the dim bulb tester is on safety, so it's got the isolation transformer active, it's on limit. I'm going to put only the one lamp, 40 watt lamp, so it's maximum limit. I'm going to actually put it on the set and switch it on here. So here goes nothing. That's right, here goes nothing, because it's not plugged in. Idiot! All right. I'm 56 years old. I got my electronic engineering degree 35 years ago, and I'm still nervous when playing with mains. Either stupid or careful. Okay, here goes. Let's see. Whoops. Well, 300 volts. Not bad. Oh God. Right, not bad. It's working. Got 300 volts. Now this is high obviously because we've got no load. The only load really is the heaters, which there aren't any heaters. And one thing else I've noticed, no light bulbs. So the light bulbs are burnt out. No smell. Switch it off and on again. Capacitors are holding their value quite well. Let's try again. 315. Good. Now let me try the heater windings. Now the heater windings, the heaters will be, make sure that doesn't flick anywhere, there's 300 volts on there. The heaters will be, one will be ground, and we've already got ground over there. The other one will be pin 4 or 5 of the power tube. Let's see if we can see that. Barely. 4 or 5, I'm not sure which one is ground on this one. So 1, 2, 3, 4, and it'll be AC volts, obviously. So we're getting 7 for nothing. 1, 2, 3, 4, 7.1, 5 should be ground. Well, close as damn it. So 7 volts instead of 6.3 volts AC. There's one other thing I want to check, and that is I want to check the AC component of this 315 volts. So let's put that back on there without touching. 313, 314 volts. You can just see that over there. What is the AC component of that? 11 volts AC. That's pretty high. So that's going into, that's coming out of the first filter cap. That seems extraordinarily high. But we've got no sparks, which is a good thing. And no smell. Alright, first power up was successful. In so much as this can be called a success. That 11 volts is too high. Unless I'm very seriously mistaken. There should be no draw. There's no current draw. And it's going straight to the filter cap. So why would we get ripple? 14. And now it's 5. What the hell's going on here? This meter is so crap. Let me try another meter. My main meter has finally died. And I'm very sad because it's actually the meter that I went all through varsity with. It was a fluke. I've passed on all sorts of other opportunities, better meters. I've always liked my fluke. And now I'm just waiting for another to arrive. But for now, we will try this little guy. Something's blinking at the front here. Ha! Look what we've just got there. That guy just blinked on it. I just tapped it. Obviously a bad connection, and it's come on. It's getting the 7 volts. Okay, let's try this again. Very carefully. So now it says 309. Well, I suppose it's drawing a bit of current now, isn't it? What's the AC component on there? 6 volts, 5.9. That's better. I'm still not sure I trust it. Once you get used to a fluke, everything else is really suspicious. Anyway, so far so good. This thing is drawing 100 milliamps. It's seeing 222 volts. The reason is I've got the maximum limit on it. In other words, only one 40 watt bulb. I could reduce the limitation on it, but I don't want to do that because it's early days yet, and I don't see what could be too wrong there now, but why tempt fate? Usually when you start messing around on the insides, you find other stuff. But for now, we've got a light bulb working. It's kind of an anticlimactic experience, but I suppose that's what we want. A light bulb is working. A 6 volt light bulb is working after all this. And I think my heart rate's come down a bit. Anyway, thanks for watching this one. I'll carry on and keep reporting back to you. Hope you enjoy this. If you do, please subscribe and select like and all that stuff. So I'll see you back soon. Thanks for watching.